Welcome to MRP classes. Let me introduce you simple trick for stoichiometric calculations. This is the mole concept of fourth series of classes. Let us introduce you simple tricks to calculate stoichiometric calculations based on balanced equation. Consider a balanced equation. Suppose this is a balanced equation. N2 plus 3H2 gives 2NH3. The number given here is 1, 3 and 2. 1, 3, 2 are called stoichiometric coefficients. But these numbers are also called the number of moles of reactant N2 or hydrogen or ammonia respectively. Therefore, stoichiometric coefficients are also considered as number of moles. See, stoichiometric coefficients of a balanced equation is considered as number of moles. This idea will help you to solve many problems. Now, there is a simple understanding on the calculation of problems, numericals based on stoichiometric calculation. This is the understanding. Please understand. For a balanced equation, these numbers, stoichiometric coefficients, the numbers means stoichiometric coefficients are fixed. Now you please keep in your mind, for a balanced equation, everybody should keep in mind, for a balanced equation, if number of moles or mass or volume of any one of the reactants or products is known. See, for a balanced equation, if number of moles or mass or volume of any one of the reactants or products is known, any one of the, it's very important, any one of the reactants or products is known, the number of moles or mass or volume of all other reactants or products can be calculated. All others can be calculated. If you know any one of the number of moles, mass or volume of any one of the reactants, number of moles, mass or volume of all others can be calculated. This understanding is very important in solving the problems. Let us check one question. Calculate the mass of water produced by combustion of 16 gram of methane. See, you want to calculate what is the mass of water, amount of water by the combustion of methane. Therefore, here a chemical reaction is involved. To solve this question, first write the balanced equation. Methane, combustion means reaction of oxygen. When methane is burned, you will get carbon dioxide and water. How many carbon? 1 carbon. That much carbon dioxide should write. How many hydrogen? 4. Half of water should write. Count the oxygen. 2 plus 2. 4. That is 2O2. Once again, how many carbon? That much carbon dioxide should write. How many hydrogen? Half of that water should write. Then please count the oxygen here. 4. 4 means 2O2. Now what is the number here? 1 mole. Here 2 mole. Here 1 mole. Here 2 mole. This is fixed. I said you, this is fixed. These numbers are fixed. Now what our calculation is? Water and methane. Please take this methane, water separately. Here 1 mole, here 2 mole. Now you have given 16 gram, please write methane and water. Now you have 16 gram methane. That's given in the question. 16 gram methane is given in the question. How much mole is it? 16 gram divided by molar mass is 16 gram. That is, it is also 1 mole. Therefore, this is our data. 1, 1, here 1, here how many moles? Make an equation. 1 by 1 is equal to 2 by n. Therefore, n is equal to, make an equation like 1 by 1 is equal to 2 by mole n. For n is equal to 2 mole. 2 mole water will be produced. How much gram it is? 2 mole water means 36 gram. 36 gram. Therefore, answer is 36 gram. Okay. Now let me go to another question. See this question. Let us go to this question first. How many moles of methane are required to produce 22 gram carbon dioxide after combustion? How many moles of methane are required to produce 22 gram carbon dioxide after combustion? Therefore, here also we have to write the balanced equation. Oxygen, how many? 1 carbon, carbon dioxide. How many hydrogen? 4. Therefore, 2 water molecule. How many oxygen? 4. That is 2. Now, our question is how many moles of methane? Methane and carbon dioxide. Sorry, methane and carbon dioxide. Sorry. Therefore, take the methane, carbon dioxide separately. Here how many mole? 1 mole. Here how many mole? 1 mole. Okay. Now in the question they have given you 22 gram carbon dioxide. 22 gram carbon dioxide. 22 gram carbon dioxide. Okay. This is how many moles? 22 divided by 44. That is 0.5. Therefore, these are our data. 1.5 mole. This how many moles? Okay. Therefore, make an equation. 1 by n is equal to 1 by 0.5. The answer is 0.5 mole. Answer is 0.5 mole. Okay, we are making an equation between these two and this is 2. Now let us go to another question. The question is this: how many of moles of carbon dioxide produced when 7.8 gram benzene burned completely? Benzene burned completely. C6H6 burned, reaction with oxygen. When benzene is burned, carbon dioxide, how many carbon dioxide? 6. How many water? 3, H2O. Okay. How many oxygen? 12, 15. Therefore, don't write a 15, 15 by 2. 15 by 2. Okay. Now you want to calculate how many moles of carbon dioxide produced and benzene. Therefore, benzene and carbon dioxide, this is your connections. Yes. Therefore, benzene, please write benzene, carbon dioxide 1, 6. Now you have 7.8 gram. Therefore, 7.8 benzene molar mass 78. This is 0.1. Therefore, you have to calculate. Make an equation. 1 by 0.1 is equal to 6 by n. What is that? N is equal to cross multiply 0.6 mole. Answer is 0.6 mole. Now we can go to this question. 10 gram H2 reacted with the required amount of N2 to form NH3 by Haber process. Calculate the volume of NH3 produced at STP. Volume of NH3, 10 gram H2 reacted with the required amount of N2 to form ammonia by Haber process. Calculate the volume of ammonia produced at STP. This is our reaction. N2 plus 3H2. Everybody should by heart 2NH3. Yes, you have to connect between hydrogen and ammonia. This is a question. Therefore, hydrogen, ammonia. This is 3, 2. Octane 3, 2. Now you have 10 gram hydrogen. 10 gram hydrogen means 10 gram divided by 2 gram, that is 5 mole. 5 mole. First we can calculate how many moles it is. How many moles it is. Therefore make an equation like this. This is 3, 2, 5. This is 3 by 5 is equal to 2 by n. Therefore n is equal to 10 cross multiply by 3, that is 10 by 3 is equal to 3.33, like this. Yes, therefore n is equal to number of moles of ammonia is equal to 3.33. Question is how much volume at STP. Therefore 1 mole ammonia is equal to 22.4 liter. Therefore 3.33 mole ammonia is equal to 22.4 into 3.33 liter. This is the answer. Yes. Now we can go to the last questions. This is the last question. Question given by NCERT. Chlorine is prepared as follows. 4HCl plus MnO2 gives 2H2O plus MnCl2. How many grams of HCl react with 0.5 gram of MnO2? How many grams of HCl react with 0.5? Therefore the question is HCl and MnO2. HCl and MnO2. See, in this question they are asking you chlorine is prepared as follows. 4HCl plus MnO2 gives 2H2O plus MnCl2 plus Cl2. How many grams of HCl react with 5 gram MnO2? Molar mass of MnO2 is given 87 gram. Therefore, this is our terms HCl plus MnO2. This is 4 mole. This is 1 mole. The question is how many grams of HCl react with 5 gram MnO2? 5 gram MnO2 means 5 gram. Therefore, number of moles is equal to 5 gram divided by 87. 87 mole. This is the number of moles. 5 gram divided by 87 mole. Okay. Therefore, you have 4 mole, 1 mole, 4 gram, 87 mole. Therefore, you can make a relation like this. 4 divided by how many moles? This is our mole. N is equal to 1 divided by 5 gram divided by 87. The 87 will come here. 87 will come here. Therefore, N, number of moles, is equal to 5 into 4 divided by 87 moles. If you know the moles, to get the weight, how should you get the weight? Mole is equal to mass by molar mass. Molar mass. Therefore, you multiply with molar mass. Mole into molar mass, you will get the mass. Therefore, mass of HCl is equal to this mole into 36.5. Okay. Therefore, the answer is final answer we will get like this: 20 divided by 87, that is mole into 36.5. Okay, this should be the final answer. Please solve this, you will get the final answer. Thank you for watching. Please subscribe my channel, MRP channel. Thank you.